Imagine your brain could only remember things as a tiny light flicking on or off. That's how computers work. Computers store everything, cat videos, birthday photos, even games, as patterns of on-off switches. Meet the bit, the tiniest memory unit inside any computer. A bit is like a light switch in your house. It can only be on or off. One bit can only remember one thing. Yes or no, true or false, 1 or 0. That's called a binary choice, like flipping a coin. But one switch can't remember your name or a photo. So computers group bits together, like a team of switches working as one. Meet the byte, a team of 8 bits. A byte is like an egg carton that holds 8 eggs. Each switch in the byte stands for a power of 2. The first switch is 1, the second is 2, the third is 4, and so on up to 128. If the switch is on, we add its number. If it's OFF, we skip it. The total is the code for one letter. For example, the letter A is 65. That's 64 plus 1. The switches for 64 and 1 are on. The rest are OFF. Now picture a photo of your dog. It's made of tiny dots called pixels. Each pixel's color is turned into a number. Let's say the color of one pixel is bright red. The computer turns red into the number 255 for red, 0 for green, and 0 for blue. That's stored as 3 bytes. 1 for red, 1 for green, 1 for blue. Each byte sits in a tiny box called a memory location. Think of your computer's memory as a huge shelf with numbered boxes. Each box holds 1 byte. The computer writes down the address of every box, like writing page numbers in a notebook. This way, it can find the box later. So how does a photo become bytes? First, the computer breaks the photo into pixels. Then it turns each pixel's color into a number. Finally, it stores each number as bytes in memory boxes. A selfie might have 2 million pixels. Each pixel needs 3 bytes for red, green, and blue. That's 6 million bytes altogether. Now here's the clever part. Computers don't remember things like we do. They store everything as patterns of on-off switches. It's up to humans to organize those patterns so we can use them. When you open a photo app, the computer finds the bytes for your photo, turns them back into pixels, and shows you the picture. So every video, every song, every game, it's all stored as simple on-off switches. The computer's job is to remember the patterns. Our job is to organize them so we can use them. A common mistake is thinking more bits always mean better memory. But a byte is just a standard size, like a dozen eggs. Bigger things just use more bytes, not fancier switches. If a song needs 1 million bytes, it just uses 1 million boxes on the shelf. If a movie needs 1 billion bytes, it uses 1 billion boxes. The switches are still the same simple on-off ones. So the next time someone says a computer has a lot of memory, you know it's not magic. It's just a very organized shelf of labeled egg cartons filled with on-off switches. Now you know the secret. Every cat video, every song, every game starts as a pattern of tiny on-off switches. Want to see how this connects to how computers understand words? Watch the full video in the link below.